All right, we've reached the end. This is the final question of this test. It asks for us to solve two different equations for x. On one of them, we're going to be using the technique of looking inside, and on the other, we're going to use fraction busters. Let's start with question A. One important thing to realize is before we attempt to look inside, well, we can do looking inside a couple different ways, right? I could consider this thing inside of the inside of the radical right now, and I could say, look, I know at the end of the day I have to be adding this whole thing has to equal the number 5, because what I'm going to have here is 5 plus 12, which equals 17. So I know that that thing inside has to be 25 because the square root of 25 is what's going to give me that 5. But if I want to back up and look at this a little bit more closely, before I look inside, it's very nice to kind of isolate the square root portion of the equation. So I'm going to subtract 12 from both sides first. And when I subtract 12 from the left-hand side, I'm left with just the square root of 8x minus 7. And on the right-hand side, when I subtract 12, I'm left with the number 5, right? So again, what does this expression inside have to be? What does the 8x minus 7 have to be? Well, in this case, it has to be the number 25, because when I take the square root of 25, I get 5. Another way to think about that is if I square both sides, right? When I square the left-hand side, this becomes the number 25. There we go. And on the other side, it's going to be 8x minus 7. Squaring a variable. I'm not going to overthink that right now. Let's just go ahead and proceed here. So now that I know that the thing inside of my radical has to be 25, 8x minus 7 has to be 25. That means that 8x has to be the same thing as 32. I'm just adding 7 to both sides. And if I divide by 8, I get that x has to equal the number 4. Now, I'm not done, right? It does say up here, it says provide a check. Does your solution make both sides the same, right? Include a check. So the question is if I put the number 4 in for x right here, what does this become? Well, if I put the number 4 in, it becomes 8 times 4 minus 7, and then I got a plus 12. And I want to see, is that the same as the number 17? Well, 8 times 4 is 32, and 32 minus 7 is 25, right? So I have the square root of 25, and the square root of 25 is 5. 5 plus 12, what is that? That's 17. Well, you can see it checks completely, right? Both of the sides of this equation become the number 17. So when x is 4, both sides become the number 17. That is the solution. And then our final question, part B. This is a great opportunity for fraction busters. And I can see that my denominator has the following. It's got a factor of 2. There's a factor of x, and there's a factor of 5. And if I could build something that had all 3 of those factors, multiplying by that would eliminate all the fractions completely. And what is that thing? Well, it's 10x. So I'm going to multiply each one of the terms by 10x. Visually, when I look at this, I can see here is a term, right? That's one term. Here is another term. Here's another term. And then I have this final term right here. So I see these 4 things. These 4 things are separated by these addition symbols on each side. And there's two factors on each of the sides. So each one of these are going to be multiplied by 10x. If I was being really explicit, I think I will, it would look like this. It's going to look like 7 times 10x over 2x. So you can see I just put a 10x here plus 9 times 10x. So I just put a 10x right here. And then that's going to equal 12 times 10x divided by 5x. You can see I just put a factor of 10x here. And then plus 6 times 10x. So this one got its 10x. So you can see this one got 10x, this got 10 times x, this got 10 times x, and this got 10x. Everything was multiplied by 10x. Now I simplify. The beauty is you can see these fractions immediately go away. X divided by x is a giant 1. 10 divided by 2 is 5. 5 times 7 is 35. So this becomes the number 35. The next one is 90x. The next one is, let's see, 12. 10, x over x is 1. 10 divided by 5 is 2. And 2 times 12 is, this becomes 24. And then plus 60x. Great. Much cleaner. I don't have any fractions to deal with now. I'm on my way to solving still. The next thing I'm going to do is I'm going to subtract 60x from each side. This is going to become 35 plus 30x. I reduce that side by 60x. And then the other side, I've got the number 24. Now I'm subtracting 35 from both sides. So this side is going to become 30x when I subtract 35 from that side. On the other side, I've got 24. And if I subtract 35 from that, I get negative 11. So this side is negative 11. As a final step, I need to isolate x. So I'm going to undo this multiplication by 30. And I'm going to accomplish that by dividing both sides by 30. When I divide this side by 30, I get x. And when I divide the other side by 30, I get negative 11 over 30. Right? So both this side and this side were divided by 30. So it's gone. So my answer for x is negative 11 over 30. And a great thing to do, especially for an answer like this, negative 11 over 30, is to store that in your calculator as x and then plug in and see what both sides become when you evaluate that. In my notes, I didn't do that. And I wish I had an on-screen calculator. So I'm going to leave that for the viewer to do. Plug that into one of the classroom calculators, or maybe on your iPhone or something, you've got a calculator, and just verify that both sides become the same number. If they do, then you know that we have the correct solution here. All right, that's it. That's the end of the Chapter 8 test walkthrough.